Okay, so I'm just going to go right out and say that this second video today is optional for you guys. The reason for that is these problems are that you're going to see from this point forward today is going to be really similar to what you saw in the first example. So this would be just if you need a little more help on this or a little more practice or a little more understanding on how to do these. I went ahead and did the first few steps of this. I might go a little bit quicker. On this second one, it just says, as an engineer for the Pepsi Company, you must design the optimal dimensions for a soda can, which is going to be a cylinder. If a soda can holds 21 cubic inches of fluid, okay, there's your constraint, okay? 21 is your cubic inches is your volume, and your volume is equal to pi r squared h, okay? It says find the dimensions to the nearest thousandth. This is where this problem is different than the first one because it's not just asking for radius. It's asking for both dimensions, your radius and your height, and they want you to actually get a number to the nearest thousandth of the can that uses the least amount of surface area, okay? So once again, you're trying to optimize surface area, and same thing as the last problem, my surface area comes from this equation right here. Okay, and if you need help on how this was derived, go back to that first video. I kind of drew it out and laid it out right here and explained how this formula was derived for area of a cylinder. Okay, so again, h is the kind of the odd variable out, so I solved for h over here. Okay, now I'm just going to keep going here, and I'm going to say 2 pi r squared plus 2 pi r, and instead of h, here I go, I've got 21 over pi r squared is equal to area, okay? And like we said on these problems, you can cancel if you're multiplying and you've got numerator, denominator. So I've got 1r in my numerator, I've got 2 in my denominator. So this becomes 2 pi r squared plus 42 over r. Or actually, let's do this. Let's do 42r to the negative 1 equals a. Okay, so again, that negative 1 is going to help me take my derivative. My derivative, because I'm trying to find my critical point, would be 4 pi r minus 42 over r to the second, right? Because that becomes r to the negative 2 just becomes same thing as putting r in the denominator, equals 0. Okay? So what I have here is negative 42 over r squared equals negative 4 pi r. Okay, I want to bring my r squared over to the other side. Okay, so it looks like this. And then, so I end up, when I'm solving for r, I'm going to end up having 42, negative 42 over negative 4 pi equals r to the third. Okay, so we can do a little reducing here. I can cancel these negatives out. 42, if I do the cube root of both sides here, if you did that in your calculator, now remember the problem says round to the nearest thousandth. So I would get 1.495 inches is equal to r. Okay, and then to find my h, I would plug it back up here, 21 over pi, and then my r is 1.495 squared is equal to h. And when you do that in your calculator, you get 2.991 inches is equal to your h. So it looks like you've designed a pretty small can of Pepsi here, one of those baby cans. So 3 inches is your height, and only about 1.5 inches is your radius. So hope you're not thirsty. Okay, hopefully that helps. Let me know if you have questions.